Hi, this is Tamer Al-Fattah, Head of AI and IoT in IngramMicro. We in IngramMicro are continuously looking for all AI technologies that can help to fight COVID-19. I'm proudly agreed with SenseTime to offer Sensecare platform to healthcare sector in Middle East and Africa. With this, we can overcome the limitation of COVID-19 testing. We can shorten the waiting time before starting to isolate the suspect patient by fast screening. We can provide scalable solution on a nationwide scale. Welcome back, Manzoor Alam from SenseTime to present Sensecare platform.
Hi everyone, my name is Manzoor Ahmed. I am the Director of Solutions and Pre-Sales for SenseTime. Today I'll be talking to you about the Sensecare Smart Health solution that is aiding as a very effective tool in our fight against the COVID-19 disease. So what is the value of Sensecare solution? Why do we need it? Number one, it is helping us in overcoming the limitations of the laboratory testing itself. Because today, when a person needs to be tested for the COVID-19 or even for lung cancer, for example, the laboratories are not enough, or most of the laboratories are not qualified for this test. So because of these limitations, we need this solution that we have. In addition, each of these laboratories do not have a sufficient amount of reagents or the material used for testing. So this is another limitation of the laboratories. Number two, it shortens the waiting time before we start isolating the suspected patients. So after collecting the specimens and transporting it to the laboratory, there is definitely a waiting time. So all of this can be shortened if we go ahead with our Sensecare solution. Finally, we are able to enable this across the nation for screening viral pneumonia, which is covering all the diseases, COVID-19, SARS, MERS, etc. So the Sensecare solution is based on CT scans. We collect the CT scans and do our analysis on top of that. It has been currently deployed in tens of hospitals across different provinces in China, the most noted being the Hubei province, from where the COVID-19 disease emerged. And of course, it has been assisted in testing across thousands of CTs, and the sensitivity right now is more than 98%. You can think of sensitivity as an accuracy from a layman's language perspective. And it has been found to improve the efficiency by more than 40%. So now we don't need doctors or radiologists to spend a lot of time to do the analysis. The efficiency is improved by more than 40%. The key features of this solution are as follows. The first one is being the fast screening of suspected patients. So we are able to screen them very quickly instead of going to the laboratories and going through the waiting list. We can now quickly screen the patients using our solution. Next, we can do a qualitative analysis of the findings in terms of lobe localization, classifications, composition analysis, and so on. We can also do quantification of what we have found. So in terms of size, in terms of volume of these abnormalities, in terms of HU curves. So all of this can be done within the platform itself. And of course, automatic report generation can be done, which aids the doctors to spend more time on analysis rather than writing reports. So this is about the viral pneumonia, which covers the COVID-19, SARS, and MERS family of viruses. And going to the lung nodule, which addresses the lung cancer, in a similar fashion, we are able to do qualitative analysis, that is doing a localization, nodule type classification, finding out the malignancy of the nodule itself. Next is follow-up evaluation. So if a person comes back later on at a different period, we can do a comparison of how these CT scans compare against each other before versus now. So this helps or aids the radiologist in finding out if at all there has been a variation. We can also do 3D visualization. This gives a 3D image of all those scans and helps in diagnosis and surgical planning. And of course, we can do the automatic report generation based on NCCN guidelines, which is for cancer-related diseases. As you can see, we can do a very high sensitivity of even millimeter level of viral pneumonia. So even those which cannot be detected using the RT-PCR test, this can now be detected using our platform. In terms of quantification itself, this is a screenshot of the platform where we can do a percentage of pneumonia infection, we can do HU curves, we can do volume of pneumonia infections, and composition proportion of pneumonia. So basically, different kinds of volumetrics are made available, which aid in the diagnosis. When it comes to lung screening, we are able to achieve a sensitivity of more than 98% in terms of the nodule dimensions itself. And it has also been found to improve the efficiency of doctors by more than 40%. Some of the statistics are given in this slide here, where the sensitivity in general is been more than 90 to 95% across the different parameters. In terms of the lung nodule quantification, again, we have different types of quantitative data, which is useful for doctors to make the analysis in terms of nodule detection, localization, classifications, malignancy prediction, and quantifying the nodules itself by their size, their volume, the density, and so on. In terms of follow-up analysis, we can always do a comparison of how a CT scan looks when a person or a patient comes to visit after a particular period of time. So we can do a comparison, we can see how this disease has spread, and quickly come to a conclusion of in terms of comparison as well. We can do a visualization interaction. So basically, we can do a 3D visualization. The doctors are able to see in a 3D view how exactly the different tissues or different parts of the body look like, and it aids them quickly to make an analysis and come to a conclusion. Finally, in terms of report generation, we are able to produce automatic reports based on NCCN guidelines, which reduces the time that a doctor needs to spend in writing reports. So all of this happens automatically, and reports get generated. We have seen a phenomenal success of this platform, especially in China, where the COVID-19 disease has spread. It has been widely recorded in newspapers across China, as you can see here on the slide. Sensecare can not only be used for lung diagnosis or to address the disease of COVID-19, but it can also be used to address different areas of medical science, whether it's bone tumor, coronary, pathology, limbs, and so on. So this can be extended to different areas of healthcare as well. In terms of the architecture itself, at the lowest level, we have the high performance computing, which makes use of the GPU servers. Above that, we have our own deep learning platform called the Sense-Parrots. It's been developed by SenseTime itself. Above Sense-Parrots, we are running different platforms like Sensecare. Sensecare is just one of them. This is the healthcare platform. Like this, we have different other platforms that are running on top of Sense-Parrots, like autonomous driving and so on. And above Sensecare, we have different applications, so clinical applications to address different diseases. So we can build a lot of applications, we can build algorithms to identify certain diseases as per the requirement of the hospitals. So at a very high level, this is the architecture. In terms of the physical architecture, at the lowest level, we have the PACS systems. This is the pictures archiving and communication systems where all of these CT scans, X-rays, etc. are stored in a hospital. So our Sensecare platform retrieves all of this and studies this and does an analysis of these images. And on top of the Sensecare platform, we have different applications, whether it's to identify lung diseases, chest diseases, bone tumor, liver. All these can easily be identified, and algorithms can be built on top of our Sensecare platform. And these are projected using end devices or edge devices like laptop, iPads, and so on. And the same architecture can be extended to multiple hospitals, and we can have a cluster of all of these infrastructure, and we can do a much more complex organization at a city level as well. So in short, the Sensecare platform is useful for predicting COVID-19 and COVID-19 disease, as well as other such diseases. And this has been widely used and deployed across hospitals in China, more specifically in the Hubei province of China, from where this COVID-19 disease has emerged. So we have references, the solution works well, and yeah, that's it from my side. Yeah, so we will need a PAC system or something similar to hold all these images. The idea here is, although we have the algorithms trained, we will need these images from the different patients for us to process. So either they are stored in PAC system, which is the industry standards, or something similar. So what we are proposing is a pretty much 100% on-premise solution. The reason for this is most countries don't want their data to go outside their particular country. So the answer is yes, it can be a 100% on-premise solution. All you need to have is a Sensecare platform along with the AI application for that particular disease, and then you are done. In case we are using a public cloud, the speed will be less because of going back and forth between the cloud system. It depends on the country where you are. Definitely, because a lot of data is getting generated. We can integrate or build a big data type of analysis and create useful reports out of it going forward.
Okay, thank you so much, Manzoor, for the presentation. It's really useful and a great solution. Thanks a lot.
All right, thank you very much.